perfect. We have another person. Start recording. Share screen. Where is this right one? This is this one. Okay. This needs a click here. Right. So during the last lecture, we started with the different plugins, and as I mentioned, there are very different ways how plugins can be generally engineered. And I think before we continue on the data panel project, we should first make a small detour into the proper way of creating plugins which have a good interoperability. So we'll start a new project for that. And once we are done with this abstract part, so this one will not include any Qt specific parts, then we will dive into how to combine this with Qt to get the most convenient mechanism while maintaining the good compatibility. So we create a new project, this time just a console application, no Qt this time. We'll call it plugin demo. And we create it. And we will need a few things for this to be useful. So first of all, we will need more projects. So first of all, we should maybe just add only a folder. We will call it interface API without a space. So there will be a few files which will be shared between the plugins and the main project, but the idea is that those files will be structured such that we can easily extend them with newer functionality for newer versions of the interface while maintaining backwards compatibility with the old binary plugin. So if you got some binary plugins developed for your software by some third party, the idea is that here, if you update your software, those plugins will remain functional and will not break. This is of course something that's very appealing to the user, maybe not so much to the companies, because they always want to sell you a new version and a newer version, and they are very happy if things break, not for their fault, of course. But we try to do it the right way. So we will create here one file which we'll call helper h. Let's see, can we do the Solution Explorer from here somehow reasonably? The way I'm always doing it, I'm just doing it like this, new file. Fortunately, we don't have a text file, so I pick just something that's empty. .h. Once we have one file, we can just copy it, and the other one will be interface .h, and then we can just add those two files. But is this running as admin? Existing items. Usually drag and drop should work. For some reason it doesn't. Yeah, and then of course we need one or two plugins, so we will add a new project. Now we use a dynamically linked library. Next, and let's call it 1, and the other one will be called plugin 2. So as you see, when we create a DLL on Windows with Visual Studio, then it creates a few more files than for a normal project, but they are not that full. So plugin 2, create. So you have this precompiled header, which is used like the stdafx file in the older versions. It just holds all the things we want to include. The framework is pretty much just an include, which is included by the PCA, so in principle you could just use the same file here. There is no need to split it into two. And we get one source file for the DLL. As you might remember, DLLs are a bit different. They don't have like just one main function like a program, because they are supposed to be called. So generally they will be exporting functions which can then be addressed by the function that generally the process that imported the DLL, but they also have this DLL main which gets notified whenever the R gets loaded into a process they get a notification for each thread created in the process. This is a very Windows thing, so I don't think libraries on any other system behaves like this. Then of course whenever a thread gets terminated, and then of course when they get unloaded. So loading and unloading the process, that's reasonable, that might be useful, because you can instantiate some internal things, and when it gets unloaded, then de-instantiate them. But getting notifications for every single thread, it's a bit overkill. And really, in case of Windows, it's only necessary if you have these different threads doing graphical stuff. So generally, these are not notifications that are relevant. Okay, so first things first, let's just load one of these DLLs. But before we do that, we will set up project dependencies, and we say that demo is dependent on plugin 1 and plugin 2. This ensures that when we build plugin demo, it will automatically build plugin 1 and 2 as well, and then if we modify something in plugin 1 or plugin 2, it will rebuild them. So if we would not have this dependency, starting it would just only load plugin demo and nothing else, which might not be exactly what we want. So we go to our main function, and we just use the load library v function. We need to include first Windows H, of course. Hash include H. Then we have this function. The W just specifies that we have a wide string, so a Unicode string. We could use A for an ASCII string, or we could use just the load library to pick whatever current convention is for the current platform. But since really people shouldn't use the non-Unicode versions anymore, I prefer to just using the hard-coded versions where we know which version will be used, and then we just provide the name. So L for long characters, login1.dll. And when this happens, it will automatically load our plugin 1, so we can put a breakpoint here. Then we will get a notification for everything that happens here. So we get 1, reason is 1, so we can see those reasons. So 1 is process loaded, then thread loaded and thread terminated, and then process detached. Now if we continue, we'll get a few more notifications. I've already finished. We should make the function do something, but as you see, this works quite nicely. But of course we want to call a function, so first of all we will need to save a reference to this loaded library. Let's call it plugin 1. And once we have this, then we can, first of all, we could purposefully unload it, so let's do that on the end. That was free library, the library gets automatically, of course, unloaded when the program terminates, but if we are using plugins, then we usually would want the ability to load and unload them on runtime. So this is what this free library would be used for. And then, of course, we want to be able to call a function inside of one of our plugins. For this, we use the getProcs address function, which takes the module and the name, but this is always ASCII, so the function names are always ASCII text. They are not Unicode, and there really isn't a reason why one would want them to be Unicode. So let's give it a name, this function. But then of course we want to somehow be able to do something with the function. Just having the address is kind of boring, so we will need some nice definitions so that we know which type this thing will be, and such definitions we can define in our interface H. So let's first include it. Include what was the path once out, interface API, interface H. Just add the typical pragma so that we can include the header multiple times if you want. And now type def. Let's say the function will return an int. Test function was the name, I think. And it doesn't have any arguments, so that's a function pointer. And we can give it whatever name we want. I just would like this to be consistent, so we have then our test function. test function is equals get process address, and this is C++. It wants an explicit typecast, so we also tell it that this address will be to a test function. There is no mechanism which would actually validate that you are casting here correctly. So you just get an address, and if the function type is wrong and you pass the wrong arguments, then you might cause a crash. More modern versions of Windows, generally the 64-bit calling convention is quite fault tolerant. So if the function would always validate all the input parameters, providing garbage to it will not immediately cause a crash. With some calling conventions in the 32-bit Windows, it is different, because the way 64-bit calling convention works is the caller prepares everything, and after the function call, the caller cleans up everything. While on Windows, initially, the 32-bit calling convention, the one that is used by the Windows API, was made like the caller prepares the things to be done, and the callee is responsible for cleaning up the stack. Which, if you are working with 20 megabytes of memory in total, is kind of makes sense, because you will be calling usually a function from multiple places. So if the function can do its own cleanup, you save on code on every time you invoke the function. And you can kind of avoid the preparation, because the preparation includes what data are put on the stack for the function. So this needs to be done by the caller, and this is unavoidable. So it's at optimization. The only downside is that if you have an argument mismatch because of a different API version or something, then the things fall apart. In our case, we will just try to always cast this correctly. And since it's also, as mentioned, we have here a 64-bit platform, then we should not, even if we do something wrong, we should not necessarily run into a catastrophic crash. And once we have this function, we can just call it as a function. Although if we just run it now, the whole thing will crash because the function doesn't exist. So basically what happens is we got a null pointer, and then if we try to call a null pointer, that causes a crash. So what we now need to do is to define this function on our plugin so that it can be exported. And we go for this into our plugin one here. We should create a file for that, so let's add here a new item h. Let's call it plugin1.h. Okay, and we'll need a few more things. Don't we have this defined somewhere? No, it's not defined anywhere. So I think if you would pick a different project type, it would actually create for us a demo class, not just an empty DLL. But apparently we need to do it ourselves. So hash if def one response, then we need to add this to our preprocessor definition. All platforms. C++ processor. This should work. So if this is defined, hash else and hash endif. So if this is defined, then we are compiling on the side of the plugin. Hash define plugin1 API and the spec the export. And if we include the same file, if you would include the same file on the side of a process which wants to include this library, then we would want to have here DLL import. In the case of the plugins, as we'll be using them here, we only need this DL export because we will not be including the header here into the program which is using our plugin. There will be just a generic interface. But if you would have a plugin, well, generally, if you would have a DLL which you want to load into your process, so for example that you can use classes defined in this DLL and more complex things, then you would need to do it as we have done it here. Well, then we will include our interface API interface so that we have this available. And then to get the right function decoration, we need to define it as extern C, so that it doesn't do the C++ name mangling. Set it as a return value of int. The name is test function, and it doesn't have any arguments. And then we can we forgot one thing that we just added here. We need to specify this here. Okay, and then let's create another file. Add item 1. We could use the DLL main, but let's just create an own file for that. Hash include the pchh and hash include plugin 1. And now we have our function, and let's return 1, 2, 3, just to do something. And then of course in our main function on the plugin demo, let's let's capture the return value. So we run it. As you see, it compiled both projects, and now, okay, this is now set to hex, but if we set to decimal, we get our 1, 2, 3 result. And in principle, we can define as many functions as we want with whatever arguments we want on our DLL, and then import it like we did here, and use it for something. Obviously, this is like the most basic sort of interface, just having C functions that you can call. So for example, the Windows API, biggest part of it is pretty much done like this. You just have functions which you call, and if you want to refer to some maintained state or object, you create some handle value, or rather you get a handle value with some create function. Then for every function that you want, you need to pass this handle value. You don't have reference counting, etc. So it is a bit cumbersome, and if one likes modern C++, then one would of course want some way to actually have an object with functions and so on, so something that is more user friendly, and we can do that. So we will create such a plugin interface in our interface H. And the important thing is that the way we create this interface must be such that whatever plugin uses this interface, and however the plugin changes, or however this interface gets extended, as long as it gets extended the right way, that it will not break binary compatibility with all the plugins. There is of course a limitation if you have defined new functions on your interface, and then you would want to call them. If you would call such a function on an old plugin implementation, then this function won't exist. So you should add some safeguards to check the version of the plugin, and then only if the version of the interface is correct, only then call the newer functions, if any have been added. So here let's define a class. Let's call it my interface, or let's call it maybe my C abstract plugin. Abstract small l, looks type of free enough, link. And the way such things are done is by creating pretty much just virtual functions. So let's first make a function that gives us the version. So int get version virtual int get version is equal 0. We will not define any real code on the plugin. The idea is that this thing will exist in memory just as a jump list to functions. It will not contain any member variables, anything, any code, just one jump list with all the addresses that we might be interested in. Later we will add more things, although there is one thing we could add already now that is quite necessary. That will be a function call to get rid of the object, so to delete the object. Since we don't want to use any code on this thing, we need to provide this as a virtual function, so let's call it release. And what this will do, this and let it be free. This will first call and free. Yeah, that's a nice description. Okay, so we have these two functions. We have our interface. What we will also need is a way to instantiate the plugin. So to do that, we will define another function pointer. We will call it make plugin. Could also call it new or something like that, but I think make plugin is quite nice. And it will return us a pointer of type abstract plugin interface. And currently here we don't take any additional arguments, but if we would want it, we could add them. So this is up to us. So let's go to our plugin one. Let's define another function. Extend C abstract plugin interface already included. Make plugin with small l. Then of course we want to have the plugin itself. So for that we will derive the class. And we have a preference with regard to the order of things. Not necessarily. But let's put it still here. So let's put the class on the top and then the function definitions below. That's generally a nice syntax. Class it's a plugin one. Public it's a abstract plugin. Public. This thing will of course now need our interface. So those two functions. Override, then of course constructor and destructor. Release, get version, and let's implement them. And here's the semicolon missing, and we need to let's move the test function to the very bottom. That will be nicer. Plugin one. Oops. Okay, so the constructor for now won't be doing anything, and the destructor as well. But let's keep them here so that we can use them for something. This goes away. Oops. Get version. This thing needs only that much code. Okay. Good. So we can here now create and return an instance of our plugin one. Depending on how universal you want everything to be, it might be advisable at this point to even use some more advanced method of using an allocator, a memory allocator, which would be provided by the calling program. But this is a lot of, let's say, extra work for not much gain, because if we are consistent and only deallocate memory ourselves from within the same DLL, the compiler should pick the right allocator and deallocate automatically anyway. So turn new plugin one, and here of course our release function is just delete this. Those don't do anything yet. Get version should return something. Return version 1. Plugin test function, yeah, that looks promising. So let's go back to our the demo is here. Let's pin a few things that will be working between more often. So the test function, we can leave it here. It's not particularly interesting. Let's just grab from the interface our make plugin name. Then here we just replace test function everywhere with make plugin, because we need to use it properly. And this of course will be then abstract in plugin asterisk plugin. I cannot call it plugin 1, I already used plugin 1. plugin1 instance. Plugin1 object. That's short enough. I mean, we could also use prefix like keep this just as. Oh, that's good. Let's call this H plugin because it's a H module, and here we call this P plugin. That will give us for short and nice names. And make plugin. This we should call make plugin1 because we'll be importing the same thing from plugin2 in a second. Make plugin2, but we have not loaded plugin2 or anything. That will of course not work, but just that we don't forget it. Right, so we have our plugin, and then we would work with it, do something with it, and once we are done doing something with it, we will before we free the library just that is a typo. Typo get replicated a few times. Release. Zack. The thing about copy and paste, you start replicating typos very quickly. Right, so we can put a breakpoint here so that we see how everything works. Let's step into the function. So we enter in our DLL, we create our thingy, we reach our constructor, we return it, and then when we are done, then of course we free it. So at this point it is kind of boring. So let's add some functionality, something very very basic. We can just define a test function on plugin1. Or actually no, let's use the get version. We already have a function. So int version 1 is just get version. So this will also work. Let's put a plugin here, just that we get our value. Okay, and we should add some sort of plugin ID. So let's get version and const. Oops, const jar asterisk get name. Well, we want to change the name later. We could get yeah, let's call it get name, and the other function will be called get. Alright, we could make this const, and we need to make this override, which will here bug out because it's not defined. So this is const, and this is virtual. The only function of override is to bug out if you make something, if you would try to override something that's not defined as virtual, which is quite useful, because then if you would define something, try to override a function which is not virtual, then you would not get the desired result, and this would of course be bad, and such a bug might be only appear later in production or something, or only in special cases. So if you can make the thing bug out instantly, this is an improvement. And as name we just call it plugin1, but we'll see. So now in our main here we could also get the name, const name plugin1 get name, and then we will do the same thing for plugin2. So our idea is that we just get different values from the different plugins. Plugin2. So oops, that was the wrong thingy. We want that. Plugin2, then this will work. Plugin2 we want to release, and library2 as well. And here we'll get from plugin2 our version and our name. Now it will crash because the plugin does not provide anything. So of course a good first approach would be to check if this actually exists. So if then -1 and printf um, printf once include stdio make plugin not found on plugin 2, and then of course we do the same thing for plugin 1. In principle, we should also check whether it actually has been successfully loaded. This we can comment out for now. Make plugin not found on plugin 1. So also here we should actually check whether this was valid. So let's add this check here as well. So if this failed, then failed to load plugin 1. That won't get last error. This is a Windows function which is so the way this error mechanism on Windows 32 works is that whenever you call a function from the Windows API, from the standard Win32 API, the function will either succeed or fail, and usually it will either be made such that it returns true or false, true or success, false on error, or it returns a valid value or a known invalid value on a failure. And if you work like this, you only get the information where worked or failed, which is kind of not very helpful. So they added this get last error function, and the way it works is in the thread environment block. So for every thread individually on Windows there is a reserved double word, so 32-bit integer field where where any function can set the last error value with using set last error. And the way the Windows API is made is that before it returns, it will set last error to whatever actually went wrong. And with get last error, we can retrieve this. And in principle, if we would want it, we could use this mechanism with our own API as well, since it's documented and quite easy to use. So fail to load plugin things, %d. And this would give us like invalid file type or file not found, something that would indicate within reason what actually went wrong. This approach is of course a little bit hacky, one might say. The way the Windows NT API works is much more clean. There you have functions which always return a NT status, which then tells you what was wrong. You don't need an extra field in your thread environment block for that. But on the other side, of course, if you have functions where you would want to return actually a value, then you have to pass a variable as reference to which to return the value. So you need a few more lines of code, and like one line more. It's not that bad, but it's more cumbersome. It's not like this convenient code writing that is quick. So even though formally it's more robust, the original Windows API was made more for convenience. Actually, I should check whether this will return null or whether it will return invalid handle, because on Windows there are two things that two ways an error is returned: either by returning null instead of the right value, or by returning a special value, for example, like invalid handle, which will then be just, for example, the value -1, so all the bits set to 1. But it looks like it just returns null on error, so this is fine as a check. So we have these two checks. Now if we of course run it, we will bug out here in this line. Make plugin not found. So what we need to do is what we need to do is now to, of course, let's be lazy, we will just copy a few files around. Plugin 1 we had here, plugin 1, plugin 1h. We'll copy this to plugin 2 and rename it, of course, to plugin 2. And then just hope the drag and drop works this time. Yeah. So we are here in plugin 2. We will change this to 2, and this as well, and this as well, and this and that. So that and that. Then we need to add this, of course, as well. Plugin 2 exports, properties, zack. Cute. Plugin 2. Okay, and here let's just go with replace everything, because I don't think we'll have like capital letters anywhere. Yeah, and now if you run it, it should be fine. And before we release it, we will get here version 1 plugin 2. And here we have version 1 plugin 1. So as you see, everything works. And the nice thing is that if we would add, let's create here a abstract plugin version 2, abstract plugin v2. So we don't, which we derive from v1. I mean, there are two ways how you can do it. You can either write like this and then drop those thingies, and just add to the new functions, which is convenient. But if you want to be super formal, then you would probably just leave this to be clear and then just replicate those functions again. Of course, the important thing is you are not allowed to change the order, so you need to add things here at the bottom always, which also might not be what you want from a standpoint of elegance. So let's go with this approach, because it's like fail-safe. So here you have no way. Whatever you do here, you will not enter a new function in between and then shift all the function pointers and cause the whole thing to misbehave. So let's add a function set label. No. Int get test value. Let's do it like this. Virtual get test value 0. Or maybe get v2 value. Get v2 value. Yeah. Yeah. It's always a bit semi-cool to invent demo names if you don't have really a purpose, and you're really just pulling numbers, random numbers from house walls. Plugin 2. So this will be plugin v2, and here it will have somewhere, and here the order doesn't matter. We can just put it here, for example, or wherever we want, because the order was already fixed by what we are inheriting from. This should have made it const, but okay, why not? Now it's not const. Override. And we will only do this on plugin 2. We will not make this on plugin 1. Let's call it get test value. That's kind of nicer. Get test value, and let's make it const for good measure. Return 1, 2, 3. Oops. 2, 3. So get test value const. Get test value const. Okay. And now the versions, of course, also changed because we have now version 2. Where was this? Plugin 2 version 2. So we go to our demo, and then we can, right, we could make it like this. Let's say we want to actually have this test value 1. But we first create the plugin, then we have the plugin, then we get those thingies. Test value we don't have, just say null for now. Then we have created the plugin, so then we check if plugin, actually we could use plugin version, we already have this cached, is 1. Then our test value function is defined as a standalone function not related to the plugin object. So we do it like this. 31, yeah. And if we here see that the plugin version is 2, then our test value will be just plugin 2, but we see it doesn't have the test value, so we can either just hardcast this. It's not really the elegant way, but a working way. We need one more bracket. Then we can use this get test value, and of course this should be our test value 2. And we should maybe print out the result. So printf in one radded, comma version Doppelpunkt %d, comma test value Doppelpunkt %d, plugin one or maybe plugin %s. Okay, then name, version, test value 1, oops, test value 1, zack, then we repeat that here, just with everything being 2, 2 and 2 and 2. Okay, let's run it. And we forgot the new line, but as you see, it behaves as expected. There are a few things which we should have to differently for production. For example, it would be convenient to wrap this in some helper object that would allow us to access, to call the functions directly in a more convenient way instead of doing it as we did here. Also, that something that would then keep also the reference count and release this when appropriate, and so on. Let's maybe do this now. Although maybe before we do this, let's do another thing. As you have seen here, we have only until now handled a very simple types like integers or strings. But what if you want to handle a longer string? So here we kind of faked it, because we just return a reference, a constant string which resides in our own memory. But if we would want to return a string that we have to generate, so something that can change, that gets complicated, because the way C and C++ works is that you pretty much just return a pointer. So this string will need to be deallocated at some point. One could of course make use of this thread attach and detach mechanics, so that we create for every thread an own object which resides in memory, in which we can store things. So this is called thread local storage, TLS, and there is some Rhenus API to create such storage slots. It's similar to the mechanism how this last arrow value is handled. Obviously, if you have multiple threads, you would not want one thread, when both threads call something, that they would change each other's arrow values depending on the order. So this arrow value is really stored per thread. So whatever other threads do, it will never affect your particular arrow value. And here we could kind of do the same. So we would define our API that we can allocate a string, and then we can do something with it. And when we call this function again, the last string that was allocated will be freed, and a new one will be created. Or we could also pre-allocate a string of a known max length. If we know that the things will never be longer than 1000 bytes, then we just allocate 1000 bytes. And we define the interface that the function per thread will give us a string, and until the function is called again, the string value will remain valid. So the idea is we have to copy it to be safe that it won't change anymore, but we don't need to care for deallocating. Or a more old school approach would be that we would have like a generally functions which return use string pointers to the normal C strings, and then you have like a release string function that you need to call on this plugin to release this particular string, which is let's say it's a workable solution, but of course it is a bit inconvenient, let's say. So there are, if we are using modern C++, there are nice and elegant ways how we can wrap objects in other objects and use some interfaces to implement the functionality such that we can handle strings in a quite convenient way. So there are minor limits depending how we how we design the interface. We could even make it such that we can really return a string directly. But the more simple and more convenient option would be to make it such that we can return that we just take something that can hold a string, and then operations are made on this object. So you are passing a argument which is a pointer to a specific storage object, and then this object gets filled, and then the object can empty itself out using the right memory allocator and the allocator. For our purposes, let's try to be a bit more fancy and create really create the ability to return a string as a return value. This is, I think, the most useful, and it's not that much more complicated. Okay, so we go to our interface. First we will add some additional functions. Virtual void set label. So the idea is that we can add the idea is that we can assign a label to every plugin so that the plugin knows its own identity. The idea here is, for example, that if you would have some logging function and every plugin would be able to log this function, then if you instantiate more than one instance of a given plugin, you would like to be able to tell their log lines apart from each other. You could, of course, implement this in a more complex way where just providing such labels is obsolete, but for example, if the plugins can open windows with, then if two plugins opens two windows, you would like at least based on the titles to be able to tell them apart and things like that. So it's quite useful in some way to be able to to be able to label your plugins. So this will take a string of our own making. Let's call it CMyString. Asterisk p name. That of course is a virtual function, and then virtual function which will return a pointer to a string, get name, get label, and of course here not p name but p label. Yeah, this one is const, and of course now my string is missing, so let's create it. Oops. So this will be just yet another abstract interface. Class CMyString. Public. Oops. Public virtual void. Actually, we should just copy it. Less typing. We could kind of say that we want a version on our string. It's, I guess, the reasonable thing to do. Actually, if we always want to have a version and maybe even a name, then we could kind of create a abstract object that can be used as a base for any object that our plugins are handling. But that gets too convoluted. Let's keep things simple. So what does a minimal string needs? It needs a virtual size t, get length. I mean, actually it doesn't need that. We could really just go with C strings, but generally const speaking, we really don't want just C strings without a terminating zero. Only with a terminating zero. We really want const to have the ability to know exactly how long a string is without counting through it. Then of course we get data. This is just VHR. We could of course indicate this here in the type, but as said, generally for strings we should use VHR always. That's for we will not even bother creating a narrow char implementation. And then of course we need some way to set the string. So let's be lazy about that. Set data, set value. We could just also call it just set, but set value is kind of nicer. And let's be again lazy. P data and c underscore t length, and this -1 to give it the option to be always just measure the length of the string if you want to return just a C string. That makes things faster and optional. And the way this default arguments work is that this just tells the compiler which argument to add when the function call is called. So it doesn't create like additional function entry points with a cached value or something like that. It just modifies how the functions are actually called. So this is safe to use in an interface. And then we will of course need an implementation of this string. So we can implement this either in each of our strings individually, or we could implement it in our helper here. So I think this is the more convenient approach, so we will do that. So the helper will include interface. The idea is that the code in the helper will be duplicated amongst the calling loading program and each of its plugins. So we will write the whole code just here in the header. We could, in principle, also create like a shared library that would then allow us to put things into CPP files, but I think since here we really want just the minimal functionality, it is fair enough, and it will not make things too slow if we just put it into the helper itself. So class CMyString. Did I call it CMyString? You could also think of a better name, maybe. Plugin string. Doesn't matter. Let's leave it at that. Right, and we of course need a different name. Semi-string implement, for example. Yeah, that would be an option. Yeah, let's go. Although we could also make it my std string, and then we just use a std string inside to keep the data. That sounds good enough. That demonstrates nicely how we can wrap objects with such abstract interfaces in order to use the stdv string. My stdv string 1. Yeah, this is good. About this. So we of course need to for public just duplicate the interface. So we need those functions. Zack. Remove all the virtuals and add override to make it very safe. Override. And it will need to do something, but for now we just here in principle we don't need the default value maybe, but for now let's keep it. So we have this, we have that. This will not need to do much. And here protected std, and this of course then needs us to include include string setting, so that we have the access to this std object, std string v string, yeah, value m value, and this is as easy as it gets. Punkt assign data, comma, this I think needs a bit more thinking, is not equals -1, then this, else vcs len from data. Okay. And of course these functions are extra trivial. Return value, value punkt cstring, return value length, get version, return 1, release the letter this, and that's it. That's pretty much our whole string implementation. And the nice thing is that in principle we could add wrapper functions for every functionality that vstring provides, which would give us much more options to use this string in a convenient way. Yeah, that's really as simple as it gets. If we would want to make this a bit more sophisticated, we could add a second setter function that would then use maybe a move option, but for our case let's really keep this as simple as we can. So let's go to plugin 1. Plugin 1H, this is the missing things, so let's go to our interface. Right, and what we also can do now, we could remove the dependency, on so that we don't compile plugin. So if we do that, so I wanted to demonstrate that we can use this version, but I'm thinking plugin 2 uses the newer interface, and we added this here to the basic interface, so we need to rebuild it anyways. If we would have added this thing here as part of the V2 interface, then we could demonstrate that, but adding it here, it will make the other one crash. So let's just rebuild everything. But this means that we will need to add this functionality to both plugins, which kind of makes us a bit more work, but not much more work. Plugin 1H. Of course, then we just add our override. Oh, I think we forgot something. Interface. This must be 0. Otherwise, it will throw us an error that the function cannot be found. Okay. We have interface. Then here in plugin 1 we also include helper. Hash include. That was interface API helper. Then we have here our two functions. Here we don't need override. We should of course somehow hold our own name, so we go here. You know what, let's add the helper here. Then it already includes string for us. In our plugin we can then protected std vstring m label, and we could here like set a default label, get name. Then set label just takes a label is equals string punct get data, and we can actually assign punct assign get data comma gets get length. Yeah, as simple as that. We just pass this here, and with this return here, things get a little bit complicated, because we want to create this string object, and then we want to return it. And the way there are two things we can do. First of all, if we don't care for proper memory allocation, we could say, like with this new here, that we really assume that we have the same or a compatible allocator. So for now we will do it like this, but for later we can implement a mechanism that will be a slightly bit more sophisticated. But let's first go to our interface helper. Zack. My string doesn't need to be my string 1, just my std string. Yeah, okay. So my string paste is like new my string, then set value, and since this is our own implementation, let's actually add some convenience features. Let's add a second set value, but that doesn't override anything, and we will just take a const std vstring reference str, and then m value is equals this. So obviously this can only be used inside our plugin, but it's convenient, so we will keep it here. So set value m label, and return string. And now we need to do the same thing for the second plugin, otherwise it will crash. So we need those two, and this plugin 2, Zack zack. Can add a comment here, v2 interface. Obviously, once we are done with our first release of the plugin interface, we would never add additional functions to our v1. We would everything add to v3, v4, and so on and so on. But since this is like still in development, then we can just be easy enough and change things. So as long as we know that no one has implemented and deployed something with the interface v1 for other users, we can safely improve and modify on our interface. We just need to remember to always compile all our plugins because otherwise we'll run into troubles. Okay, so we have here plugin 2, plugin 2, and then we said we want this default label to be created. Get name. Good. So now we should use that. We can go to our plugin demo, and let's for now just do it on one of the plugins. Let's do this one. So we will need, of course, our objects. So here we also include helper. Actually, helper includes interface, so we don't need the interface include anymore. But let's leave it here for now. CMySTDB string label 1. Set value plugin 1 test. Then on our plugin 1 we can just call set label with a reference to our label 1, and then of course we kind of want to get this out, so p label 1, since this will be a pointer, is equals plugin 1 punct arrow per plugin 1 arrow get name, and we can maybe scope those things so that we see that they work correctly. And there is one annoying thing that here we cannot plugin asterisk, that we cannot, this of course the abstract thing, so it's just my string, not my string v. Get name, that's not get name, that's get label. Get label, yeah. That we cannot the letter, I mean we could and it would probably work, but if you would have libraries compiled with different compilers that use different allocators, then that would end up in a crash. So if we want to clean this up, we need to release it. Just remember, release will call delete, but this delete will be the instance of the delete inside the particular function, particular DLL which has created the thing. So we'll put a breakpoint here and a breakpoint there, and we can go to our, where is it, helper. Actually, let's just put the breakpoint here, that will be most convenient. Then we put a breakpoint here because we should reach 2 other breakpoints before we reach this one. Let's run it. Oh, we have a bug somewhere. Great, we forgot a semicolon somewhere inside helper. Yes, we did. Zack. We forgot something else. Yeah, we forgot a semicolon here as well. Let's hope this is the last one. Yeah. Okay, so first load symbols. I just load symbol this one. Once we loaded all the symbols, we see it. So from main here, when we get out of the scope, instance on our plugin demo exe of this destructor is invoked. So when we continue, and then we go to main, we see here we called release, and then the release will call the same destructor, but its instance inside plugin 1. So if anything would to change in how delete implementation works, we would always arrive at the right this implementation. So what you want to avoid is to have like some of the interactions with the memory being done from code residing in one module and another part of the interaction done with code residing in another module, because you don't have guarantees that the code didn't change in the meantime. So this is why we are using this release mechanism. And now, of course, this is kind of inconvenient, to be honest. So we would like to use the abilities of modern C language to make the whole thing somehow more convenient for us. So we can create additional helpers that will help us with that. For example, something that will just then hold on to the string and get rid of the string once we no longer need it. So we can create this as a template class. We can create it in many ways. So we could either go with a simple implementation and then make it more complicated, or we just start with the complicated one. So let's go, I think, here instantly with the more complicated version, since it will allow us to be more flexible with what we can do. So template, oops, class T, class C my PTR, so my pointer, public explicit C my PTR, T asterisk PTR. Oops, that needs a double point. Then we will need some helper object. So what we'll basically do is create a helper object to with a reference count. As you already should know from our exercises with our CX string. Struct as my PTR, T asterisk PTR, null PTR, volatile long ref 0, zack, or asterisk, just asterisk m. So we save a line by defining the variable m of type s and PTR asterisk here just at the end of our struct definition. That looks a bit better. Right here, so we have here in our constructor. Generally in the headers you try to save lines, so it's good to write the code a bit more compact. M is equals new as my PTR, and since this my PTR thing does not cross module boundaries, at least it shouldn't, we can implement it here with just a new PTR, and then of course we need a copy constructor. Const reference other, which is which will use a function we need to add ref other other.m addref we will implement in a second, and then we would need a destructor, of course, whenever our pointer goes out of scope. Dereference. We could just call it just ref and deref, or deref, yeah. Deref doesn't do anything. Then we need the assignment operator. Zack reference operator is equals const reference order that we should have copied. That would have saved us some typing, and here we just ref order dot m, and then return asterisk this. Then a few more operators, but now let's add these two missing functions. So void ref as my ptr asterisk p. First the ref, in case something was already referenced, is equals p, and interlocked add reference a ref, comma 1. You could also use interlocked increment. I think we used that in the other implementation, so let's go with the add, and then that's done. Void dref. So if no m, then return. There's nothing to do. Else if interlocked get add, same thing, but this time with -1, and if this is equals 0, so then if ptr then mptr release. Yeah. It doesn't know what this will be, so it doesn't offer us IntelliSense, but it will work. The letter m, and in any case m is equals null ptr. Okay, this is this, and then we just need a few convenience operators. So we want the arrow operator to work on this object, so t asterisk operator arrow const return m question mark m ptr, or else null. Given how arrow is used, that will just crash, but we want prefer a defined crash at null instead of a crash on something. Then let's add a boolean operator bool, so that we can use this as a boolean expression to check if this thing is something or is nothing. This is actually if m and mptr is not equals null. So we check if we have something, and if this something is actually something. And then we also want another operator that is pretty much identical to this operator, t asterisk. So if we typecast this thing, this one doesn't need to be const. If we typecast this thing to this type, then we won't be able to access this. Yeah, and then we will be able to construct other nice things out of this, although good enough. Now let's first keep this as is. So the idea is that now we go to our plugin where we use this thingy, and instead of implementing it like this, what we can do is we can just see my ptr of type see my string by using the interface, the generic interface, not the p label. And then we just assign this value here, and then we can do something with it, and when this goes out of scope, it will automatically delete itself. So let's add maybe here a printf looking 1 label doppelpunkt %s. We need capital S to indicate that it's a vchar, although if we would use the wchar version of printf, then we would need a small s. So it's always like the opposite char type. And here, as you see, we have all the functions which have been defined on our see_my_string available with the arrow operator on our own pointer object. So get value. No, get data. We called it get data. Gives us the C string. Yeah, let's run it. We have some mistake somewhere. Therefore, there is an equals sign missing here. And that's not how we write autre. And more typos. Missing semicolon. And now again we reach here obviously from the previous case, which is super simple. And if we run it again, something didn't work as expected. What did we forgot? We did not. Did we remove the breakpoint? No, something's broken. Let's debug that. So if we put a breakpoint here, we should see what happens when we are leaving the thing. So we have here a call to the distractor through a jump table. Oh, deref, yeah. Deref is good. This exists. Did we screw up the definition? This should be now. Wait. We did not. Here. RF is of course 1. We could in principle. Yeah. This looks better. Okay, then let's run it again with the bug fix. Okay, this one happens. Now here I will remove the breakpoint and run again, and voila, we arrive now through main close of scope to the distractor into the deref, which has dereference and sees that it's now 0, and calls our release, which invokes the distractor implementation, which then calls our distractor before it frees the memory. And this way we already have quite a convenient mechanism of communicating strings between our plugin and our calling process. And the next step will be to make this even more sophisticated. So for example, what one might want is some shared means of memory allocation. As I already mentioned, currently each module uses its own allocator, which if they get mixed might cause issues. So here, to avoid that, what we do is we can give a set of functions to the plugin that the plugin will be using for the different operations. And strategically we can do two things. Either we can have a global function like this one, which we would call maybe a set API, which will give us the ability to set a few functions which the plugin can internally use, and then it can use it at any time. Or we would go and provide this API to this make plugin, in which case then every instance of our plugin could have an own set of APIs that it can call on the parent of the on the loading process. Generally, if we don't have a particular plugin architecture in mind to start with, there is not really a big difference what is better. Maybe it's a bit more convenient if we have to specify the API each time we create a new instance, because then we are sure to not forget it. If we would have to call a set API first and then make plugin, we could of course forget forget that and then end up without our API being instantiated. But as said, this works more or less either way. There are different, of course, strategies how one can handle this string. So we could, in principle, have a string implementation which does not have a release, and instead we provide as an API function a function that will create a string for us, which will then be handled externally, and then it can be easily deleted outside. For our use case here, we could just add like another field called, I don't know, description or something like that, that we will then use to demonstrate the other mechanism, how you could communicate arbitrarily sized objects between the two different plugins. But this time, let's do that on the plugin 2 and on plugin 2 only. So we will go to our interface and add a set description and get description. And this we can then just pass a const char t to description. And then the idea is that we'll just be receiving a const char back, which will be managed by the plugin. Although that is a bit annoying, but we can, as a demo, I think this is simple enough to implement. So plugin 2, although is it a good demo? I mean, it showcases the mechanism, so let's use it. Yeah, we can implement it in a way that will be showcasing it more than necessary. Let's say it like this. So we have this thingy here. Let's override. And then here we will have just a description. And then we want, of course, the implementation for these two plugins here. Plugin 2. Description. Okay, and it's, since here we just get some memory which we don't need to keep hold on, we just can send set m description is equals description. So we'll just create an instance within our own object that will manage this, but here returning will be the more funny part, because in this particular use case we could just return this and say the description won't stay valid after we have deallocated the string, the plugin, I mean. Maybe we should keep this as a showcase and just add another function which will then showcase the thing where you actually have to construct something. So here we have set description, set label, and then we will add another function virtual against const char get total info const equals 0. This thing will then have to combine the name and the plugin name and the label and the description and return it as a string, which then is not supposed to be cached. So you could, of course, kind of cache it and then just return it, but the idea of this demo is really to show the other way of returning things. So one where we cannot cache it. So we have this, then we have a std string info. Info is equals get name. Let's not like this. So info is like get name plus equals L. So we had plugin 1 semicolon label double point first maybe version, doesn't matter, let's just go with label plus m label plus like, let's put it in the next line, description plus description. And now, of course, we cannot return C info, because as soon as this function exits, C string of info becomes invalid. So we need some way to return a vechar which will be handleable by our outside caller. So what we do for this, we first will in the interface here create this object for our interface. So let's call it class or struct. It doesn't need to be a class. Struct as my API or just plugin API. Yeah, I don't know. Let's go with plugin. Plugin API sounds better. And for now, it will have just a very simple thingy, but we need to define it. Void asterisk p malloc cz size. So pmalloc capital M looks better. Malloc semicolon. And asterisk is missing here. Did I forget something? Type def, of course. Yeah, that's all. Okay, and then as we said, we want to either pass it when we create plugin, or we would want to pass it globally, but I think we will go with this create plugin approach. So make plugin takes a plugin API as an argument, which means we need to change all our make plugin calls to support this. Oops. So in plugin 1 we will just take the value but not do anything with it because we don't need it. In plugin 2 we will do something with it in a second, and then of course when we call it we will need to use it. So as plugin API, actually we could define this globally here. Yeah, API, we should initialize it with zeros. API punct malloc is equals void asterisk my cz this will just call return malloc. So it will use the standard C memory allocation function to allocate some memory, but this way it is ensured that it is the right one, malloc. And maybe you should also make a wrapper for free. My free void asterisk pa ptr. Then we'll add the other one as well, so we'll have a full basic memory management capability on our API. Of course, we need to add def void asterisk free void asterisk ptr. Okay. It sucks. So my free is void. Okay, and then when we use a make new, we just pass this to it. And here, where was it? That one, make new. Oops. Suck. Good. And now we go to our plugin 2 where we want to actually do something with it. We could, for example, here on plugin 2 add this as a argument and keep a copy. API PAPI. So when we go here, then we will pass this there. Of course, then here we will need to API. And now what we can do is we can use this. here to, well, we'll try. This is not const in this case because we get this memory to play with it as we want, so it should not be const. Right. So pay info is equals pay API malloc info punct length plus 1 times size of char unterstrich char. This needs a cast. We will be returning this return. Oops. And VCS CPY. It might complain that it's not the safe version. Punct C string, but let's see if this compiles or if it complains. Nope, it's complaining, so let's go with the safe version. Comma or use size. Let's take it in words or in size in words. Okay, in this case we don't do this, we just pass length plus 1. Okay, now it should not complain, and we haven't used it yet. So let's remove this breakpoint. And here in the second case, all info is equals plugin2, which we need to cast here, get total info, and then actually this replaces that, printf %s comma total info, and then can my free all info. We could just also directly call free, but it's nicer to use our own wrapper that makes it more clear what's happening. And this works as expected. The description is missing. Didn't we set description here? Probably we did not. Set description, no. Set. Didn't we set description anywhere? No, we definitely did here somewhere. No, we only set label. We did not use set description for anything. So let's just remove the description from this printout here. Because that would be a little bit boring. And as said, we could, instead of providing our malloc and free to a plugin so that all the plugins can use it, we could do it kind of the opposite way. That the plugin just gives us a pointer, and then it has on itself a free function that will free things for us. Okay, so any questions at this point? Okay, if there are no questions, then let's see how we can improve this. So one inconvenience here obviously is that we always need to cast the right type. We could in principle, of course, just instantiate the plugin with a cast here directly as a type 2. But what one might also want to do is to have some sort of wrapper that would make it so that we don't need to test the version, or actually we should test the version, but to make it so that if we forget to test the version, we will not end up in a crash, but instead in some sort of graceful error message. So one approach one could make here is that we take our smart pointer, well, we have it instantiated. I will use it for the string. Okay, so let's just create a normal class here. Class, oops, it's a plugin. It's a plugin plugin wrapper. Mm. And this will always handle the v2 version. Public. Okay, let's go to our plugin interface and grab everything. And here, that nothing of it will be virtual. We don't need this. Yeah. Then protected. We will want to hold onto the plugin, so we could actually use a string here, something like this. But with my plugin was just C plugin interface. Yeah. Let's see, interface, plugin interface v2. We always take the highest version for this application. ptr. Then let's int version, cache the version number. Is this actually compatible with an empty instantiation? It is not. So let's add a constructor that just doesn't do anything. M stays 0, or M needs to be 0 here, and I should is equals null ptr, and then we will need we could add a set function, but then we can also use here this thingy to set that. And there is also another strategy which we could also use. So we could have this plugin wrapper, which then just takes a plugin API of the oldest version. And then using this we can instantiate this thing in a very convenient way. But we'll need to cast this to the version, to the highest version. Zack. And in principle, we don't even need to add a destructor, because even if we don't have one here, the destructor of this object will be called either way. But there's one thing we want to do. We want to check if this and if this, then m version is equals ptr get version, or else it will be 0. I think the initial version was version 1 anyway, so this is fine. And now we just implement all the functions as wrappers. We should go for a single line implementation. So return version. Well, this one is actually easy. We just return the cached version. We don't need to do it again, but the other one already will get something. Return. If version is greater equals 1, then return ptr get name as a return null ptr, and this pattern will just now repeat all the time. So well, kind of, if we of course have no return value, then we just go with an if. Set label per label. If this would have like a return value true or false for success or failure, then we would of course be able to return here an appropriate error code. Get test value was already something from our version 2. So this needs to be at least version 2. Get test value, or since it's an integer 0. Description. Oops. We set descriptions or something from version 2, I think. So set descript. Okay, this is an if also. 2. Zack. Set description per semicolon. Then here again. Oops. Zack. Get description on null pointer, and of course 2. And get total info gets pretty much the same treatment. Just that we check the other function. Yeah, And now we can use our plugin wrapper everywhere. So for example, let's use it really everywhere, like here. So plugin wrapper p1 from make plugin. Changes, of course, one thing, that now we will be referring to everything via the dot instead of the pointer. So obviously at this point we would either want to use the plugin wrapper itself as a use the pointer of the plugin wrapper itself so that we can easily pass it around, or we would make the plugin wrapper as such also reference counted. But since we already did the other thing, this my PTR reference counted, then we don't want to replicate here demonstrations. So let's just go with this approach. Yeah, and of course, since we have this wrapped, we no longer need to release this manually. And of course, the same thing, actually plugin 2, we just leave the old way. And then we can add, like this is all infos 2. And of course, if all infos 2, then do this, else this, all infos 2, all infos 2. And we can use the same code here for all infos 1, but this time it will not enter this branch, since we don't have the right plugin version. So this is just plugin 2. We should not call it p in this case, just plugin 2 dot get. So let's quickly fix that. Sorry, it will be also plugin 1. Plugin 1, zack. Here, plugin 1. Okay, and then if we put a breakpoint here, we'll see that plugin 1 should not be triggered. This one, because our wrapper has seen that the version of the interface is not correct, so a call to this function would not be valid, and then it will just return some known invalid value to indicate that we cannot use this function on that plugin. So this already makes our handling here substantially safer. If we would want to refer to this as a reference, we could just use some existing smart pointer like from hash include memo like from STL. So here blah 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 std side pointer type plugin wrapper plugin in 1 is equals make shared we need this here. In principle, we could simplify this auto. If we are using STL and modern features, let's use them. And now we are again switch plugin 1 for a plugin arrow. But since it's a smart pointer, it will get out of scope. And if we want to force it out of scope because we need to force it out of scope before we unload the library, here we can use plugin 1 dot reset. Oops, which will then make the pointer go out of scope, which will in turn trigger the destructor of plugin wrapper, which will then in turn trigger here the destructor of our small reference thingy. I'll just add here an empty destructor just that people see that there is one. Okay, let's put breakpoints here. Well, one is enough, and back in our plugin 1 destructor, so that we see that everything gets freed before the libraries get freed. Okay, let's run it. Okay, and we see when we trigger reset that the destructor of plugin 1 is invoked, and then of course the destructor of plugin 2 was invoked by release, as we've already seen, and then we can free the libraries. We could now, of course, look into some more sophisticated way of also reference counting the libraries. But in principle, we could already let Windows do this if we would add here another pointer for a library and call load library multiple times. So Windows will count how often a load library for a given library was invoked, and then it expects the same amount of free library calls, and thus we can call free library multiple times, pretty much as many times as we called load library first. So that would be an additional improvement to our smart pointer. Here in our plugin 1 we could have we could improve that, so let's do that. So let's first see plugin 1, plugin 1. We can comment this out, and let's comment all of this out, and the new version would be basically this would just take the name of the library and the reference to pdata, and we can make it such that we can use both strategies, so we don't, it doesn't need to be exclusive. So it would be first name of the library, const dash per file, and then our plugin API per API. This will need to be changed. This will remain, and we will need to add a module lib. So lib is equals to add library v from file, and if this is not true, then we return. So here we will have one check line. If we need to add a function to this thingy before version for pool is valid, const return, and we can just in principle say if version is greater 0, then it's valid. Was it here? No. Yeah. If this punct plugin 1 error is valid, so if it's not valid, then we fail to load plugin 1, but without an error code. We don't know what went wrong. Just failed to load it. And to differentiate, let's call fail to create plugin 1 instance, and we don't need to write DLL. And want to return -1, of course. Right, so we are here, we are there, then we need our this thing here. This get pros address does not allocate any memory, so it just gives us an address from within the plugin, or rather the DLL, so it does not require any release or anything. So if this failed, then also return, just return, and if it was successful, then mptr is equals this thing. We have an assignment operator, so we can use it, and we said that this takes as argument make plugin, and the make plugin takes the API. Then we create, wait, this thing is v2, yeah, this needs recast because this is v1, and if it was, and let's keep this design, if it's not, then return, and then if everything was fine, then we set version, and version should be not 0. And then we need, however, to add here something. If and we need to initialize it. Okay. Null. So if lib, then and this adds a problem because we will now free library before we deallocate the object here. So we will need to clear it explicitly, which pretty much just means we called our deref function, which in principle then means we could put the function on top, but let's to keep with the design. Just add it. What do we want it? Maybe here. Void clear the ref. Okay. So now we have ensured that the thing is freed, and then here we have ensured that now the library is freed as well. In principle, when we create such a wrapper, we don't need to use this smart pointer thingy. This is just kind of a convenience in case we would want to share the reference. In case here, the way we used it here, the idea would be that if we want to share the access to this plugin, we would just we'll just make multiple instances of plugin and access them. So use the smart pointer. Since we don't modify any variables here on this thing after it was created, we don't need to add any thread synchronization, so multiple threads can on the same C plugin wrapper object call different functions. The plugin internally would need to implement some synchronization if the plugin wants to allow for being accessed from multiple threads. If the plugin would not do that, but we want to enable it to work this way, then we would actually need to add here our own synchronization to this object, or externally synchronize whenever we want to access the pointer. So there are different ways how to do it. But for simplicity, let's keep this as is here. And what else? Yeah. So here we actually are not using this reference counting feature of this pointer, since we always will only have one reference in this particular case. And of course, if we would somehow get this out of this object, then we would still have the problem that then the library might still get freed. So we should really not try to extract this pointer from here somehow. Okay, so I think this is quite a feature complete showcasing of creating and interacting with plugins in a safe and interoperable way that gives us a lot of compatibility. We have not in full depth dived into the approaches where we would use some shared memory management or something. We only showcase it very simply with this get total info case. But I guess it is enough to have the more convenient ways of doing things being shown. So such mechanisms with this abstract interfaces are really nice. One could of course make the whole thing a bit more elegant. Wait, we have somewhere a small typo. We have one closing bracket too much. And oh, this doesn't longer exist. So let's comment it out. Right. Where was I? Yeah. So this, as said, is the most convenient way. We could make it more formally elegant by introducing like a shared my object or abstract object that is then shared by string and plugin. We could actually do that. That is really quick. We just call it C abstract object, which has the release function, and this is derived from that, and we don't need release here. And abstract plugin is also derived from the same thing, so we don't need the release there. And then what this actually would enable us is to change a helper to a non-template class. So we can quickly do that. So if 0, then we copy the thing, hash else, hash end if, and this is then no longer a template class, it's just my ptr. And instead of t, we will always use abstract object. I just have to check, do we include interface? Yes, we do. Let's see, so there. This that will not this will not work great, because then we break the ability to error and get the right function. So we will just leave it as a template. It is much more convenient. We could have made the template being derived from an object that just takes this abstract object and only adds this two operators. But I think that makes things too convoluted. If we need a template anyways, then let's leave it at that. I'm thinking what reasonable homework based on what we did here today I could invent for you. And let's maybe start with something kinda simple and kinda creative. So it will be very simple, but it will require some inventing of names and variables and stuff like that. 06 11 2025. So and the following demo plugins. Let's say one plugins using the interface method demonstrated in this project. So plugin 1. What would be nice? I guess having a serial port would be nice. It says serial port with the following functions. Open, guess a string, identifier port, comma, and enum, the Baudate, and other enum with the parity. Let's not make it too complicated. This is just fine. So we need a few more instructions. So for each plugin type and own interface from abstract plugin interface. Yeah, from abstract plugin interface should be created, containing functions. Functions are for the plugins use case. So this would need this to something to open. One open, right, and to the controller. Simulation of to the actual port. Read returns a string red. It always reads nothing. Well, and close. With no argument to emulate close. The plugin should return if the if thought was open. The plugin should yeah, close. Or not, or an empty or null when the plugin was open or was closed. Return true when the plot is open, else false. Okay, that's like one simple thing. Another thing, let's say it's local pipe, which has the same interface as the serial port. What is meant for PPS, comma, which always writes to the console, which returns nothing, which writes to the console %s %s is the string, comma, put using prefixes in wrap and turn off pipe. Okay. 3 local TCP socket, the same, just right socket, but it will need a different open function. In principle we can make yeah, here here would take pipe name and ignore the baud rate. Yeah, that is pretty simple. Now maybe a fourth plugin that does something completely different. Let's call it a ADC in, which represents AC limited analog to digital converter. It should have an own interface and this with the following functions. Well, open oder begin one moment please. Sorry, that was the wrong number. Okay, and which the flag to not begun and read values. A string of 10 comma separated random numbers. Yeah, I think this is simple enough, but will give you some experience in working with the interfaces. One thing we probably should have added, but now we are already running out of time, so we will not, would be at this level here, sorry, at this level here, not just version and name and label, but also some sort of get type, so that we could validate if the type that we got is what we want. Although, I mean, we have 3 minutes left, so we actually maybe should just edit. This will be quick. Oops. Get type. And then we in interfaces will define hash define type 1 is 1, plugin type 2 is 2, and the other plugins will have other types. And we will keep this as a global reference. Of course, if we would be mixing different types from different vendors, then we would define it such that probably you use some of the bytes to identify the vendor, which should be unique and ideally requested to be assigned to you, and then something on this line that then you add additional characters later on. Pattern plugin type 1. Oh, actually both plugins have the same type. Plugin type, let's say demo, because plugin 1 and plugin 2 have the same interface, just different versions of it. So plugin 2 should return the same thing. Plugin 2. We go back to our interface, and actually we could use a literal. Since we have an integer, we can use a literal like this, and this will basically be an integer where these characters are turned into their hexadecimal values and inserted into memory front to back. So actually, if we want this to read demo in memory, we need to write it in reverse. OM add demo. Yeah. Okay. And then we would have like other plugins like plugin port, and type ADC, we can use less characters and it will be just filled up with zeros. I'm just not sure from which end. In C, A will be the furthest, so we need to add a 0 character here if we want this in the right order. Because this will be the, yeah, and a reverse of this, DAC, we didn't make a, DAC, we didn't make a assignment for this type, but let's keep it like this. Okay, so I will upload the homework assignment and the project to the Moodle as well as the recording, and we will see each other next week. Have a nice weekend. Bye bye.